Hi, everyone. Great to meet you. My name is Amiram. I'm a co-founder and a CEO of Upwind. Here with me, we have Ophir Zahavi.
Hi, nice to meet you all. My name is Ophir Zahavi. I manage the cloud engineering of H2O.ai's SaaS solution.
And today we're going to show you a very technical session about the challenges and implementation of H2O, of different cloud security features and capabilities using Upwind. And before that, let's just get introduced what H2O does and what Upwind does, and we'll take it from there. And just so you know, we want to keep this like super interactive. So if you have any questions, please just raise your hands. I'm going to listen to the question and answer it on the spot. Sounds good?
Okay. So, about H2O. H2O is a startup company based out of the Bay Area. It's an AI company, of course. H2O is a global visionary leading in automated ML. H2O is trusted by more than 20,000 organizations around the world. And we recently announced our new Gen AI and RAG software called H2O GPT. H2O comes in a couple of varieties. It can be installed in the customer's on-prem environment. It can be installed in the customer's own cloud account, or as a managed solution called the Managed Cloud, which is the product that my group leads.
Thank you. Now we'll just talk for 30 seconds pretty much about Upwind. So what Upwind is it's a cloud security platform. And a cloud security platform will provide a set of features and capabilities to secure cloud infrastructure end-to-end for customers. And we look at this in 3 dimensions, 3 layers. The first of all is securing the cloud, which is configurations, identities, who has access to the cloud, the different services of AWS that are in use and how they're being externally exposed, vulnerability management, malware scanning. This is like how to secure the cloud itself, usually done through agentless discovery. The second layer is workload security, which is you have the cloud, and then you have workloads running on the cloud, which is the compute infrastructure like EC2 and containers and Fargate and Lambda and all of that. So this is what we call workload security, where customers want real-time visibility of the network, of the process execution, of the access to files, investigating what started, what happened, if something is deviating and doing something suspicious. This is the workload security piece. And then on top of that, like on top of the workloads, we have like your apps, what you're building, the customers. And this is where you want to have application security of understanding the API catalog, testing the APIs for weaknesses. So all of this together, this is what we define as a cloud security platform, and this is what we do at Upwind for our customers.
So let's start with the challenges that H2O had in securing its cloud. So before partnering with Upwind, H2O had one of the leading cloud security products out there. It was good, but it had a lot of problems that caused us some issues in our environment. First and foremost, it was very costly. The previous cloud solution, the security solution that H2O had, was very costly and was not very efficient in doing its work. Second thing is that in the previous security solution that we had, the console or the UI of the security platform was very noisy. That means we got a lot of vulnerabilities shown. It wasn't very clear to what is most important and what is least important. And we lack the actual visibility of understanding what are our top vulnerabilities that we need to address, what is the most important things that we need to do in the morning when we wake up and we open up our environment. Another thing is that the previous solution that H2O had was not really talking the DevOps language. It was very security oriented, and for me and my team as DevOps engineers and platform engineers, it was very hard to understand what we needed to take out of this platform and what are the actual action items that we need to continue with. So, why Upwind? First and foremost, Upwind talks the DevOps language. Upwind is more DevOps oriented, and it is easier for DevOps engineers and platform engineers to understand what are the key takeaways from the platform and what is most important to do to make your platform even secure in just out there. Second thing is the way Upwind is installed. Compared to the previous solution that we have, Upwind installation was much easier. Upwind has a eBPF-based agent that's deployed on our EKS clusters. And using that eBPF agent, that's all we need to secure an environment. So using that eBPF agent, we're able to scan and understand what's happening in our environment and what's going on without the need to add or install additional components. It's just a single Helm chart that we deploy, fairly easy with almost no configurations, and that's it.
Fair. Let's try to break out a myth together.
Okay.
In your previous solution, it was a mainly agentless solution,
Yes.
right? So, and you're saying that Upwind installation was easier than an agentless solution. How come?
So, with our previous vendor, it was agentless. It was that was how it was marketed, but we had to install to connect the platform to AWS using IAM to discover the API. We had to install a separate EKS cluster that would scan disks and would scan the data stored in the EKS servers. We had to install another another cluster agent that would run in each and every EKS cluster. And it
Across
was
all of your accounts?
Across all of our accounts. If we have tens or hundreds of accounts, that agent is deployed everywhere, that IAM role is deployed everywhere, and that host scanning cluster is deployed in each and every region. So, of course, it's agentless, but it wasn't really consolidated into a single agent just like we have in Upwind. With Upwind, just a single agent, and we're up and running. True stories, it took us around 24 hours to uninstall and install Upwind. The turnaround time was very quick. One of the key points that we were looking into when we migrated over to Upwind was basically breaking down the silos between our security and DevOps teams. With our previous platform, it was mainly the security team that was looking into it. And that really created a silo between my team and the security team, because the security team needed to go into the platform, triage the issues, analyze everything, come up with a solution, open a GitHub issue, and let my team start handling it. With Upwind, because they really talk DevOps and their infrastructure is their UI is more oriented to DevOps and is easier to understand, and everything is in context, I can have my team go into the platform, see the issues, and solve them right away. The main, I think, takeaway from the UI and the way Upwind work is that everything is in context. Everything that we have in the platform is tailored to our environment. That means if there's a CVE, we can know if the pod or the host running the CVE has active internet ingress connections, if it has IAM attached to it that has privilege escalation, or if it's using compromised assets. And that's the main benefit in using Upwind, so that everything is in context and is relevant to our environment. On the screen, we can see an example of the vulnerabilities page, and we can see the funnel. So this is one of the key features that we saw and the key advantages that we saw when doing the POC with Upwind. We can see that there's a total of 2,000 vulnerabilities found, but if we go to the right and we see the end of the funnel, there's only 7 that are critical, because they are classified according to if that compute has active ingress connections, if the vulnerability is exploitable, if there's a fix or there's not a fix. So everything is in context, and it's very easy for DevOps and platform engineers that are not necessarily security engineers to understand what's most important and to handle that. So that really is a very big advantage in minimizing the time or the turnaround time from finding a CV to solving it.
And then, Ophir, I think we discussed about it, that once you find the CVEs, there's another process begins. Like, you need to go find the developer, you need to go understand when the CVE was introduced, in which branch, in which build, in order to go and solve it. and do it, because in many times, like, your developers would prefer speed over risk, and you will find yourself with CVEs in production. Here is a way that we work together on showing a full map from that specific CVE into like the specific pull request that introduced that CVE.
Yeah, so this is, again, very important for us in H2O, because understanding the context and understanding who introduced the CVE and seeing it very clearly on the screen and understanding the entire pipeline that took that CVE from a PR to a deployment, to a build, to a deployment, and to the actual customer environments is key. That way we can easily identify every CVE that was introduced into the system. And the most important part here for us is that we identify these CVEs on the spot. So compared to other cloud platforms, cloud security platforms that scan the disks and try to analyze it and to understand what CVEs are, this is done in runtime. So once we identify the CVE, we can see it on the spot.
And you said runtime, and it triggers me to look at this screen. Like, sometimes when you scan for CVEs, you scan both like your running images, but you also scan your registries, and you scan like many other different like tags of that image. So then you end up with like having the same CVE multiple times because of different image tags. But what you really want to know is like, what is the scope of that specific image in my production and who runs it? So we're able to like work on it together, but like what you see on the screen is the life cycle of a specific image tag. In this specific image, you see this is like image called API on the upper level, and it's tagged as 163. You can also see that there is like different version of that API's image running in different versions on different resources right now in production. But like there is one resource called API that runs that specific version. So that really alleviates the team that's responsible for fixing the vulnerabilities. Let's say if you have like lots of API vulnerabilities on that image, on resources that are no longer running, these tickets on Jira will be closed, because these are resources not relevant anymore. The fact that you have a CVE lying there somewhere, it's not a critical issue for any customer. So this is really an ability to like really get a good grip of all the CVEs and all the resources containing that CVEs with that specific image tags. One more thing to mention is when going from the funnel from 2000, as you mentioned, Ophir, all the way to the right of 7, and when you go and see the 7, so these are the 7 that went through like the CVSS score, the environmental scoring, and now you want to add your business context. So you click on more filters, you'll click on tags and labels, and then on tags and labels, you can add things like, just show me things related to my production environment. So, and then you're ending up like, you can even shrink that 7 into like 2, because these are only the ones who are related to my specific business context. So you can add it here, and then save a view of like, this is just my prod E&V, and I save it through my entire org. And now instead of looking at even 7, I look at 2. So that's even like a further optimization that like goes and like also taking into account like specific tags and labels related to the customer. Why don't we move on? Yeah. Any questions on this?
Okay, so as I said earlier, with Upwind, H2O is basically able to achieve end-to-end visibility and runtime security. That means that the end-to-end visibility basically means that we're able to see everything that's happening in our environment. There's a network map in the Upwind UI that basically maps out the entire environment and all the connections, all the network connections, all the resources, and that there's a single place where I can see my entire environment in context, who's talking to who's talking to the internet, what countries, what DNS records are being contacted, and everything is in a single place and in real time. There's also an option to go back in time. So real time is nice, but if I had a breach or an issue in my environment and I want to go back in time, I'm able to scroll on the timeline and go back in time and understand what happened in my environment previously. You want to show that?
This is really inviting a quick demo. So I will click and you can talk. This is exactly what you said, Ophir, which is this is the runtime graph that we generate. And you can see here, this is a one AWS account example that shows, if I'll just like zoom out, you'll see that the way we're structuring the map is internet ingress comes from the top to the cloud, and then internet egress goes down, leaving the cloud. And then inside the cloud, we're going to see the different services being used. And like, you guys are using many AWS services. Obviously, this is a demo environment, but you can see in this demo environment, as I double-click on the production EKS cluster and I look at the microservices, I can actually see very quickly the microservices that are talking to AWS services like RDS and like Elasticache. And not only like to RDS and Elasticache, I can also like point into a specific RDS database that is being used. If we focus on it, so Ophir, now you can know very easily which microservices are actually accessing your RDS. And even more interesting, like what you can see here is, let's say you want to enforce in your environment that you have a gateway that talks to your RDS databases. You can actually see really easily like how different services talk to a RDS service, like if they contact it like directly or indirectly. So pretty easy to map.
Adding to that, again, I can't stop talking about context when it comes to Upwind. We can see on the map, if you scroll a bit up, we can even see on the map that the pods that are deployed here have a Istio sidecar. So that's another advantage that I can understand what's going on in my environment. And we can also see that there's little icons like the bug icon and the arrow into the world, so we can understand that this service has ingress traffic, it has a CVE, and the scoring under it. So the map of the map in Upwind really gives a very holistic view and also a deep down view. So I can look at it as higher as I want, or I can really deep dive and go into each resource and focus on it and see the network connections and the resource overview and understand what network connectivity it has and what resources it's using and where it's connected to.
Well, Free, I also remember that one of the most important things for you when we first met was understanding your environment in a topology way, getting information from layer 3 and layer 4, which is what we see here on the network, but also being able to immediately get access and map the entire API endpoints.
Yeah. So, of course, we protect our environments with WAF gateways, and we make sure that everything is secured to the best of our ability. But still, we didn't have any visibility into what's going into the cluster. Not every request is blocked by WAF. And using the Upwind solution, we found a lot of bad actors that were passing WAF because they looked okay, and they were trying to spray or attack the environment, just trying different prefixes and paths in the environment to try and reach some important information or to find something of importance. So this is a very good visibility that we had. We gained into the environment in understanding what's happening, even though we have our security in the perimeter. This really gives us more of an in-depth view into the actual APIs that are passing the WAF and are not being blocked and reaching into our environment.
Amazing. And let's take it like one step even further. Like we understand the network on layer 3, layer 4, layer 7, but now it goes all the way into creating baselines of the services. And baselines, Ophir, we go a long way, and we know that securing containers and servers is completely different than securing laptops, like installing an EDR, right? Like laptops is the most dynamic thing that you have. You always download files and install software on it. But on containers, it's completely the opposite. Once you deploy a version, once you deploy software, like it needs to run like set of commands, and like that's basically it. So can you tell us how baselines for your containers are helping you?
So as you just said, the baseline in the containers help us understand if there's any anomalies in our environment. I could say that as an AI company in our SaaS solution, we offer a set of tools, and with those tools, we also have Jupyter Notebooks environments. And as you said, those kind of mimic or are like computers because you can, it's an IDE that you can use and you can run anything that you want. And using these baseline processes, it's very important for us to understand what is happening in the container. If someone's trying to gain lateral access or lateral movement between the containers, if someone's trying to, just net map all the RDSs in our environment, or
we've seen in many other cases Bitcoin miners through Jupyter notebooks.
So this was a key decision when we introduced our notebook service to gain visibility and to have that visibility into what's happening. Because previously, before we had Upwind, we knew we had a notebook service, but we didn't really know what was going on behind the scenes.
Yeah, it's really changing. It's really changing the way that security is able to provide information into like other groups in the organization and really like back it with data and track it in the right way that you want to look at it. As you said, context. Let's move on to identities, Ophir. I think like this was a big thing like, when we discussed early on. You guys were an early customer of ours, and you really pushed us on identities and how important it is to bring like human identities and non-human identities into the platform and connect the context together. Tell us more about the use and why it's so important across all of your accounts at the H2O.
So, as a SaaS platform, apart from the AI part, the most important thing for us is to uptime and security. We need to keep the environment as secure as we can. Customers trust us with their data, and we need to make sure that we do everything that we can possibly do to make sure that their data is secure. Having runtime security and CVEs and everything, that's nice, that's cool, but we're just as strong as our weakest link.
Sure. And
that's where the human identity come in. Using the Upwind platform, we're able to see all the identities connected from AWS SSO with Okta to the actual user in the account. So we have visibility, as we can see on the screen, to the entire path of the user. We can easily see if the user is classified as a risk. If you go out of this, and we can see the little crown, the high privileges.
Yeah.
So we can easily see if there's a policy that the user has that is considered high privilege. We can easily see what permissions it has and start limiting it so we can achieve least access.
And then this is human identities.
Yes.
But then we have non-human identities. We have Lambda execution roles, and we have Kubernetes service accounts, and we have IAM roles for EC2 instances. So how do we make sense into even, you guys are using Carpenter.
We are.
So how do we make sense even like understanding what the Carpenter service account is actually doing?
So again, just like human identities, non-human identities are just as important. Our solution as a SaaS or PaaS, you can call it, we have workloads that we're dynamically spinning up according to customer request. Because of that, our platform has permissions to execute and do things in Kubernetes. And the easiest thing for a developer to do is just, add all the actions, add all the verbs, and, run with that and have a cluster role binding, and he has permissions to our entire cluster, and that leads to bad places. So using Upwind, we're basically able to assess what permissions each role has, each pod has. We can see if it has AWS permissions via the details that we can see on the screen. So we can map the service account that's attached to the pod that has a certain role in Kubernetes and a certain role in AWS, and understand the entire context and permissions of that pod.
And net, this is like changing the way like your day-to-day, because you can rest assured and you can always like take an identity, understand if it has high privileges, and then take it with context like identity with high privileges on a pod that has a vulnerability and is doing something suspicious, or like this is just like raising the criticality of everything. And second, for the day-to-day operations and compliance, when you need to go and tell the auditor which identities have access to what, you just can have it in just one click of a button.
Yeah, this also helps us very much. The reports from the identity helps us with our compliance programs and our quarterly audit of all the permissions that we have in the environment. And a funny story about this is that usually before we had Upwind, our security engineer used to go into the platform, go into the EKS, download all the cluster role bindings, try to assess what's important, what isn't important when it was used, and start, working backwards to the developer and trying to solve that problem. Here, as the team is more using the platform and is involved in the platform itself, those type of drifts are automatically seen. We see it with our own eyes. We can act very fast on that, and we can go directly to the developer and say, here's the YAML that you have, here are the permissions that you have. We're seeing that you're not using ABC, please take that down. So it really cuts down on the time from detection to actual action.
That's amazing, which takes us back to our next points we wanted to discuss, which is when we met, I remember that the biggest thing that we could have provided value for you, even as a young company, was to take like multiple tools that you were using. You had to pay for a leading product, but it was not enough. It was agentless, so you had to like also back it up with another product and then another product. So you end up like as a startup company paying for 3 different products, let alone the complexity of managing it.
Yeah, so as you said, I think the key takeaway that I got from the process of migrating into Upwind is that we always look at the price of the platform that we're buying. We have a yearly or fee that we pay the platform, but we never look into the resources that it's consuming in AWS. And what we found that with our previous solution, our previous cloud security provider, we paid them a fee that was quite big, but we also paid a very big fee on the actual clusters that it was running in our environment to scan disks. And that's something that a lot of people overlook. And at the end, when you understand that you have an additional fee that you're paying your cloud security provider and you're paying AWS, that number sometimes even multiplies.
Sure.
Not only that, as Amiram said, we had our cloud security platform that we purchased, and we had a whole wide services in AWS enabled to get the visibility into our environment. So when we migrated over to Upwind, we not only got offboarded our previous cloud security provider, but we also consolidated Upwind with a bunch of security tools in AWS like GuardDuty, Advanced Shield, what else we had? Inspector, exactly. So we had the ability to consolidate it, and not only did that reduce costs, it also gave us a single pane of glass to see everything that's happening in the environment, because
it's amazing.
Previously we had to look at several different places to understand what was happening.
That's amazing. Which takes me to the next one, which you talked about it, but it's sometimes like it sounds like a cliche that like you deploy a security product and then you have lots of alerts and lots of noise, but in your case, I remember it was overwhelming, and I even remember like during even the POC that you were able to extract value after just a few hours after installing Upwind. Just take just the top of the funnel and just use that and start like working backwards with your developer. That was a big deal for you.
Yeah, that's a very important point. You know, when you wake up in the morning, you start your work, you get a cup of coffee, and you open all the different providers that you have. And I remember that I would always open up my cloud security provider, and I would see a bunch of graphs, a lot of graphs, not a bunch of, a lot of colors, a lot of alerts, a lot of vulnerabilities, and it was overwhelming. And the end case of that was that I would just close it and say, okay, I'm going to deal with it later. Or I tell our security engineer, listen, there's a bunch of things. I don't understand what's going on here. I need your help. And that not only reduced our security posture because we weren't addressing the open things.
True.
It also reduced the engagement of us in the platform. Today, as it's easier to understand what's going on in our environment, our engagement is higher. With higher engagement, we understand better what's going on in our environment, and we can easily understand what needs to be done and not what doesn't need to be done, what's most important to achieve today, and what can wait for next week.
Amazing. We talked about that. We showed that in the demo. And the CI/CD part, I want to open that again. We're talking right now about even deploying Upwind in your shift left practices. So then developers can come and through their build, it's going through an Upwind scan. But the change here is that it's not only going through an Upwind scan, it also brings runtime data into the build scan. So then a developer can see, it's a non-blocking, the developer can move on, but the developer can see the runtime context of that specific build. If that build is going to land on an internet-facing resource, or a resource with high permissions, or a resource that has the environmental scoring at the end of the day that will be dangerous for that specific CVE, you can see it on the build time. How do you think about that, and how that's going to change the way the developers are engaging with the platform?
It's not going to change. It's already changing. So it's bringing the developer closer to the actual actions of what he's doing. The developer can easily see what's going to happen if he merges the PR, what's going to happen after we build and deploy. It bridges that gap or that disconnect between devs, ops, and security. Having everything in the same console at build time, at runtime, and understanding the full context and the full changes that will happen according to that build or deployment brings the developer more to our side and helps us bridge the gap and mitigate things faster.
Exactly, and we always talk about we want to have our cloud secure, but we also want to have developer experience. And sometimes developers will prefer speed over something else, and the business prefers speed over something else. And it's really nice that you can come in one place, increase the environmental context of that risk, and then really save a lot of time from the developers of chasing ghosts that they don't need. And second, go back together into one screen and see, hey, I had this build. This build was do not deploy. I chose to deploy, or I'm choosing to deploy, but here I see all the context, and I can even review it together with security later, and I can go back and fix it. So I think here's a good opportunity to say thank you for pushing us on asking these features and capabilities, because at the end of the day, that's really moving the needle on security and experience.
This is a must-have for us because as an AI company and in the AI realm with Gen AI, we can't, wind down and deploy things and do things slower. We have to stay on track and do things even faster today with all the buzz around AI and Gen AI. And this helps us bridge that gap. This helps us run fast, deploy fast, understand the context, understand if there's a vulnerability or there's something that needs to be fixed, and do that faster. And deploy once again to fix that.
I think it was a team effort.
Definitely was.
But at the end of the day, it was with you and Asaf and Yogev and the team, and it was highly successful implementation. if Asaf was here as your manager, what would he say beyond that?
I think that Asaf, as leading both me and the security engineering, would say that the biggest takeaway from the Upwind platform for him is bridging the gap between security and DevOps. For the managed cloud, for the H2O SaaS solution, we always try to keep that gap as minimum as possible. Get the security guys doing Terraform, get the DevOps guys trying to understand security. But that gap was always there and was always very visible. With Upwind, we're able to bridge that gap. We're able to talk the same language, understand things better, and collaborate better on the platform.
Yeah, Ophir, I cannot thank you enough for the partnership. But I think this is a great opportunity to really bring together all the capabilities and all the things that we've done together. And I think it's just the beginning. Security is just securing what the cloud has to offer, and what the cloud has to offer is always changing. So Kubernetes is just another milestone in the way that we're going to consume compute and release services. And we're just at the beginning of a huge AI revolution. And it's amazing to see how you guys are executing over there. Just really excited to see what comes next. And I want to thank you for coming here.